everyone, I'm ThereaseRamya from the Department of Physics, Nirmala College for Women. In this video, we are going to see about the introduction to semiconductors.
Introduction to semiconductors. Under this introduction to semiconductors, today we are going to see about Bohr's atomic model and the energy levels and energy bands. Next, we are going to see about what is the classification of energy bands and solids. First and foremost, according to the Niels Bohr's atomic model, he put forward in 1931 that the protons and the neutrons are present in the middle and the electrons have the circular orbit. The first orbit is the next to the nucleus, and the next one is called as the second orbit. And he told that the electrons revolve around the permitted circular orbits. And he also put forward that whenever the radius is larger, the radius of the shell is larger, greater the energy of electrons. Next, he also shows the energy level diagrams. The nucleus is denoted. These are the energy level diagrams. First, the center portion is called as the nucleus, and in the energy level it is represented as nucleus. And the second shell, first shell is called as the 1s level, and the sixth one is called as the 2s level, and it goes on. These are the energy levels. First orbit level, second orbit level, and this is the energy bands. Energy bands are a range of energies possessed by an electron in the solid. See, this is shown in the pictorial representation, the levels next to the electron, nucleus levels. First shell, first orbit, second orbit, and the third orbit. And it is given as the bands. It is called as the range of energies possessed by the electron in a solid. That is called as the energy band. And these ranges of energy possessed by electrons, we'll call this as the energy bands. And the classification of energy bands includes range of energies possessed by electrons in the solid. And first is the valence band and the conduction band, and the next is called as the forbidden energy gap. So there are three classifications of energy bands. First is valence band. Valence band says that the electrons in the outermost orbit, the valence shell, it is called outermost orbit, is called as the valence shell. The electrons inside the valence shell are called as the valence electrons, and it is called as the range of energies possessed by the valence electron. So once again, valence band is the range of energies possessed by the valence electron. And next is the conduction band. Conduction band is the next level of the valence band. Here, the conduction band is the range of energies possessed by the conduction electrons. These are called as the conduction bands. The electrons present inside the conduction band are responsible for the conduction of heat and electricity. Next is the forbidden energy gap. This is the most important thing. The gap between the valence band, or the space between the valence band and conduction band, is called as the forbidden energy gap. Here, this forbidden energy gap is also called as the Fermi level. So forbidden energy gap is the separation between conduction band and the valence band energies. It is also called as the measure of bondage of valence electrons to the nucleus. And next comes the classification of solids. Solids are basically classified into insulators, conductors, and semiconductors. Now, first and foremost, we are going to see what is an insulator. Insulators have the forbidden energy gap is very large. That is, the distance between the valence band and the conduction band is more. That type of material is called as the insulator. So the characteristics of the insulator will go like this. It does not conduct electric current. The valence band is full, whereas the conduction band is empty. And the best examples for the insulators are glass, wood, mica, and etc. Conductors. So conductors, as we all know, there is the overlapping between the valence band and the conduction band. So the electrons can easily jump from the valence band and can be transferred to the conduction band. Due to this overlapping, the electrons can easily conduct heat and current. So the characteristics of conductors are, it can conduct electric current and also the heat. It has large number of electrons in the conduction band, which is responsible for the conduction. And the best examples we can say as metals is the semiconductors. These semiconductors in day-to-day life has a very numerous applications that in the electronics. So at normal state, these semiconductors does not conduct, whereas while applying some external energy through some other means, the electrons in the valence band can easily jump to the conduction band due to this Fermi level, that is forbidden energy gap. The energy gap between the valence band and the conduction band is very less, so that the electrons can easily jump from the valence band to the conduction band. So it starts conducting. So some external energy is required for the semiconductors to conduct heat and electricity. And the characteristics of semiconductors are, electric conductivity lies between conductors and insulators. It has small energy gap between the conduction band and the valence band. And the examples are like metals, silicon and gel. And next, let me check the understanding level by testing yourself. Pause the video and try to answer these questions. According to Niels Bohr's atomic model, the electrons are permitted to move along dash orbit. Second one, the range of energies possessed by electrons in a solid is called as dash. Dash is the measure of bondage of valence electrons to the nucleus. Dash is a separation between conduction band and valence band energies. Give an example for semiconductor. The answers are, check with your answers. First one, it is circular orbits, energy band. Second one is the energy band. And the third one is the forbidden energy gap. And fourth one is the Fermi level. And the final fifth one is silicon and germanium.
Thank you all for watching this video.